Hello everyone, this is Zhang Zhang, and this is the last homework of stochastic process. And for the first question, we have seen that we want to prove when xt is real and WSS process, we know that it has autocorrelation function R and power spectrum function S, and we need to show that R is real and even, and S is also real and even and negative. And firstly, we have seen that if xt is real, and then we use the definition to calculate R, we can write like this, and this is maybe complex, but it is real. So we can write the expectation is like E in the E of the xt minus ext plus tau and xt. So both these x are real. So it's obviously that the E is real. And now we know that the Rxx is real. So we can write Rxx minus tau, writing like this one, and this is also real. So we can write like E of xt minus tau times with xt, and because xt is WSS process, so we can write like R, it is the time interval, so it is R tau, so they are the same, so we can see that it is even. And okay, in the second question, we know that the power spectrum function could be write like integral of autocorrelation function for the Fourier transformation. So after this transform, we have seen that the S of minus omega is equal to S of omega. So it's seen that the SSX omega is also even. And for the non-negative, we use the proportion of the notes from page 61. We have seen that if we have got a system function, h omega is equals to the 1/2 power of 2 pi times delta omega minus omega 0. So this function's equation, this equation's expectation function square is written like this, and this is equals to SXX omega 0, because we know that the YT square must be non-negative, so the expectation function is non-negative, so SXX omega 0 is non-negative. Also, we have known that if omega could be anyone, we take any value of omega 0, then we can replace omega 0 as omega. So the power spectrum function as omega is also non-negative. So this is for the first question. And for the second question, we want to prove that these three functions may be a power spectrum function or an autocorrelation function of our WSS process. And to prove this, we must know that if and only if the power spectrum function is non-negative, then S omega must be a power spectrum function of a WSS process. Also, if S omega is non-negative, so the autocorrelation function is if autocorrelation function and if its Fourier transformation of S omega is non-negative, so this function must be an autocorrelation function. So all we have to do is to prove that the power spectrum function is non-negative. So first one, we see this equation, and if we know that if V is equals to omega, and we see this function as a power spectrum, and we see that we can write as omega is equals to e in the power of minus magnitude of omega. So this is an exponential function, and this must be non-negative. So therefore, the Fv could be a process spectral function of WSS process. And also, if V is equals to tau, so we get the Fourier transformation of this R is equals to 2 over 1 minus omega square, and this is also non-negative. So therefore, the F tau is maybe the R tau of the WSS process. And for the second question, we see that if V is equals to omega, and this equation is of course non-negative, so therefore Fv could be a power spectrum of WSS process. And but sorry, the second, I don't know how to get the Fourier transformation results. I only know that the Fourier transformation can be written like this, but I don't know how to solve it. And for the third question, this is a band filter, and we know that the filter domain is from minus A to A. So if V is equals to omega, then as omega is a non-negative function because it is only have two values, 0 and 1. So in the third question, the Fv could be a power spectrum function of the WSS process. And if V is equals to tau and we have F tau, we get the Fourier transformation of F tau. This one equals to 2 times with sine omega A over omega. So we cannot definitely to determine whether this equation is negative or non-negative. So in this case, the F tau could not be a autocorrelation function of WSS process because we cannot prove that S omega is Fourier transformation of S omega is always non-negative. Okay, that's all. Thank you.